recording here. Okay, and let me hide this floating control. Hide floating meeting controls. Perfect. Okay, so what we did is I'll just open this one Excalibur, and what we discussed in the last class is our SRE, right? So we learned what is Kubernetes, okay, and what are the what are the important things that Kubernetes gives us. Like what are the we discuss about the quality of the product. What means about what do we mean by quality of the product, and how does having what does we do to increase the software quality in production. Okay, so we use different technologies. One of them was Kubernetes. One of them is Kubernetes. Okay, but there are other software as well that help you to achieve those quality parameters like load balancer, high availability, fault tolerant. Okay, so we discussed about gap theorem as well in the last class. So gap theorem is nothing but it says you cannot achieve consistency, availability, and partition all three in the same system. So this is what the theorem says. Okay, fine. So today we will discuss what is Kubernetes, okay, and why there is so much buzz about the Kubernetes cluster. Okay, so let's go to Kubernetes here. Okay, so Kubernetes have a Kubernetes.io. Okay, so this, okay, maybe I'm not sharing the right screen, my bad. Okay, nobody complained about it. I don't think if you were listening. Okay, so can I get okay, what happened? Okay. Okay, guys, students, like, can you hear me? Like, can I get a note from you?
Yeah, and you.
Okay, so you can see my screen, right? You see the documentation, Kubernetes.io.
Yes, yes.
Okay, thank you. I was doubting myself. Okay, so the Kubernetes IO, this is the website for Kubernetes. Okay, it contains all the documentation that you requires to understand Kubernetes. Okay, so Kubernetes is very vast. It's so vast that you need like 10 years to get all the certification from Kubernetes, right? So Kubernetes, there are many certificates that people do for the Kubernetes itself. Okay, Kubernetes Associate, CK, like Certified Kubernetes Architect, and then Certified Kubernetes Developer, right? So there's a developer profile based on Kubernetes. There's a profile called Architect profile, right? So what they do is they design and develop application that are Kubernetes native, right? So what is Kubernetes native application? The application that can be deployed in Kubernetes in a proper, like you can deploy anything on Kubernetes. Any application can be deployed in Kubernetes. But why do we use Kubernetes, right? You can deploy application in VM as well. Why do we need to use Kubernetes? You use Kubernetes because you need an application that provides high availability, load balancing, fault tolerant. Yeah. Okay. So these properties you need to enable in an application. So that is why you deploy application in a platform which supports all these properties. Okay, so Kubernetes is one of them. So to design an application which have all these properties, you need to know how to implement that. Okay, and that is why people do Kubernetes certified architect course. Okay, so these course tell you how to make your application Kubernetes native. Okay, so there are different kind of architecture, and there are many types of objects in Kubernetes that you can create. Okay, if you don't know about that, it probably you will not be able to create a production grade uh, application deployment. Okay, So without wasting time, let's go on to documentation. Okay. Um, so the first thing is, let's see why Kubernetes. Okay. So if I go to the overview of the Kubernetes, and this is what we discussed in the last class. So why do we need Kubernetes? Because Kubernetes provide you service discovery and load balancing. Okay, it provides you storage orchestration. So using the single storage, you can distribute the storage among multiple containers, right, in a very easy way. And in Docker, right, we saw that you can use a local folder, right? But here you can use any type of storage service, like you can use a Google Drive storage, you can use a S3 bucket, okay? You can use a use some Azure cloud storage, you can use Google Cloud Storage, okay? So you can use the network file storage. So all kind of storage servers can be enabled in Kubernetes. Okay, so your application can take storage from any of these available services. So that is what Kubernetes provide you. Automated rollouts and rollback, right? So whenever your application are upgraded, you roll out them. Okay, and whenever the application doesn't work, you need to roll back. This is called rollout and rollback. So when your application upgrades, it is called rollback. And if after upgrade your application doesn't work, you have to move to another version, which is that is called rollback. So it provides you automated rollout and rollbacks. If the application doesn't work properly, Kubernetes will automatically deploy the older version, which was the last working version. Okay. Self-healing is one of the major feature of Kubernetes. So if you are getting interviewed for Kubernetes role, they will ask you what is self-healing. Okay, so self-healing is a feature where Kubernetes restart any failed container. Right? If the container fails, it automatically restart using some some internal way to resolve things. Like, so if the container fails because of the memory, so the Kubernetes will try to run the container on some other node where it has more memory, right? So this is what Kubernetes automatically tries. So it try to heal your failed application. So the application here we are talking about containers. Okay, so it replaces containers, kills container that doesn't respond. Okay, and if the container doesn't respond to user health check, it also do that. Okay, so secret management, batch execution, horizontal scaling, dual stack, all these are properties of Kubernetes, and that is why people use it. So what is okay, this is why let's not discuss this. They are like, when once you start with Kubernetes, you will understand that. Okay, so let's quickly see what are the components of Kubernetes cluster. Okay, and before let's see the Kubernetes component quickly. Okay, so this diagram shows you the Kubernetes cluster component. Okay, so in any cluster, okay, so what is a cluster? Can anybody tell me what is a cluster? What do we?
Cluster is a collection of machines together.
Yes, exactly. So cluster is collection of machines connected together, right? So this is machine one. Okay, I say node one. Okay, and there is node two. Okay, let me move like here. Okay, so this is node two, right? And there is another node called node three here. Okay, so I'll make it node. Okay. And this is our special node. I'll tell you why this is special. Okay, so in a cluster, so we are talking about Kubernetes cluster here. Okay, in Kubernetes cluster, there are one or many nodes here. Okay, there you see two nodes here. Okay, I can just make it a little bigger so that I can accommodate more nodes. Okay. Okay. So this is node N. Okay, and why it is node N? Because there can be n number of nodes attached to Kubernetes. Okay, so in Kubernetes, you have one or more nodes and these nodes are controlled. These node connects to some another node which we called as control node. Okay, so this node is control node because it controls all other nodes by some services. Okay, so this control nodes contains some services. Okay, some services. Okay, control node contains services to manage the whole cluster. So cluster manage cluster components, cluster uh, components slash objects. Okay, so the cluster. Okay, so they are when you talk about cluster, when they come together, they do some useful thing, right? So how do you so if you are living in a society, right, there should be one society manager, right? So what he do is he takes collection from all the flats. He manages things, right? He make sure the garden is all fine. He removes all the disputes, right? So in a society, you elect one of the member, or you elect multiple members that controls all the activity in the society. Okay. So how do they do it? They it may be a group of people. Okay, so the group of people, one person will be planting the tree, right? One person will be responsible to make sure the mopping happens in the staircase. One person will be responsible to make sure the gardens are clean, right? So the component, so there, so in society, these people are managers. Okay, so the managers in so this control node, okay, is a collection of services that manages all the activities in the cluster. Okay, in Kubernetes, the main component of the main part, main services that are part of the control node are, okay, one of the services API server. Okay, API server. Okay, so API, what is API server? Okay, as the name suggests, API server is responsible for hosting APIs. Okay, but I don't know why this is like different here. Okay, so we'll just delete it. So API server, okay, API server is responsible to provide API access to the cluster. Okay, so you want to do some useful thing from cluster, right? How do you do it? So you do it by calling the APIs of the cluster, right? So let's say so one of the API is get pod, right? Okay, and another API is get services. Okay, so we'll talk about what is service, what is pod. So all these are the API, and these APIs are provided by API server. So API server is an application that provides you API interface to Kubernetes. Okay, so when someone want to talk to Kubernetes, okay, so let's say this is a client. Okay, because he need to do some operation in cluster, he need to talk to cluster, and he will do this using API server. Okay, so the API server is the core service that provides external connection to cluster. Okay, so client will talk to API server. This is fine. The other main service is controller. Okay, controller, right? And there is one more service called etcd. Okay, and the other service is a scheduler. Okay, so these are the four core services. Of course, there are other services like Kube, a networking service like CRI, right? So CRI is container runtime, because you are running containers on node, right? So you need a runtime engine. So CRI is nothing but container runtime interface, okay, or container runtime engine. So what is the role of controller? So the controller is responsible um, to manage the nodes. Okay, so which node will be down, which node will be up, which what node will be scheduled for next deployment. Okay, so all these things are controlled by controller. Okay, so etcd is the brain of the cluster. Okay, so it's a database. This etcd is the database of the whole of all the objects that are in the cluster. So this is a key value database, KV type database. It's a brain of the cluster. Okay, so cluster have some state, right? Everything has a state. So this is the HCD is a database which contain all this the state of the objects in the cluster. Okay, so what is the IP of the node 1? What is the IP of the node 2? How much memory is allocated in node 2? How much disk space is on node 2? Okay, what pods are going to, what containers are running on node 1? Okay, how to access that container. So all this information is stored in HCD. Okay, scheduler is responsible to schedule your pod. Okay, schedule your container. Okay, let's say the client says run a container. Okay, so scheduler, so it will first go to API service say that I need to run a pod. Then it goes to scheduler and say it says to scheduler, hey, I want this pod to be running, right? So what scheduler will do is it schedules to run this container in one of the node. Okay, so scheduler is responsible to schedule deployment of the objects. Okay, fine. And CRI is nothing but a container runtime engine. So one of the container runtime engine we have seen is Docker. So Docker is a container runtime engine. Nowadays, Kubernetes comes by default. By default uses container D. Okay, because Docker nowadays is getting a little enterprise grade thing, so they will start charging for something. So they started to use container D as their default container engine. Okay, so this is fine. Okay, so this is cluster. These are the main cluster component of control node. Okay, on the node side, right? What connects this node to control node? Okay, so the service that connects node 1 to control node is kubelet. Okay, so every node will run kubelet. Okay, every node will run kubelet. Okay, so the kubelet is responsible to connect the node to control node. Okay, so this kubelet will connect, this kubelet will connect control node to node 1. Okay, control node to all the other nodes. If the kubelet is down, the control node won't be able to see the remote cluster nodes. Okay, so kubelet take care of that. So there is another service called Kube-Proxy. Okay, Kube-Proxy. Okay, so Kube-Proxy is responsible to provide you networking related services. Okay, so IP of the container. Okay, so container in Kubernetes world, the shortest unit is pod. Okay, so container is we have containers in Docker. Okay, in Kubernetes we have pods, right? So pod is the smallest unit you can create in Kubernetes, right? This is the smallest unit that you can create in Kubernetes. And pod internally talk to CRI to create container. So we don't create container in Kubernetes, we create pods in Kubernetes. Okay, so Kube-Proxy is another service that that defines the networking of the networking in the nodes. Okay, and this internally provides all the IP, the DNS, and all the thing in the Kubernetes cluster. Of course, like this is just a very high level overview. There are many things that Kubernetes do internally. Okay, but just you need to know that who connects node to control node, it is kubelet. Okay, so how do you access Kubernetes cluster? You use by using API server. Okay, and what is the brain of the Kubernetes cluster? HCD is the brain of the Kubernetes cluster. Okay, and who schedules pods? It is scheduler that schedules the pod. Okay, so the components are so in the same diagram here you see we have components. Okay, so these CCM, API, scheduler, HCD, Kube controller manager. So these are CM is again manager, multiple cloud providers, API, scheduler, HCD. These are part of control plane. And on the node, you see there is a Kube-Proxy running and the kubelet is running, right? So kubelet connect to API server to give details about the services running on the node. Okay, So same thing you can see from the diagram, right? So this is the diagram, okay? And you can get more information about the component in the link here, okay? In the link here, I'll share you the link, okay? All right. Okay, so now we know that what are the components of a cluster. Now let's see uh, what are uh, what are the main objects that you create with Kubernetes. Okay, so you already know about containers, right? Containers have images. Container runtimes is nothing but the software that runs container, that provide ability to run container. Okay, and this is what is something you need to know before you move on to Kubernetes. Okay, so let's talk about workloads. Okay, so what do you create on work in Kubernetes? And before jumping on here, like so I think we had enough theory for so far. Let's try to get access to Kubernetes. Okay, so one of the easiest way you can get Kubernetes cluster is using Killer Coda. Okay, so Killer Coda is a platform, okay, where you can uh, you can do hands-on to many DevOps tool, right? If you want if you want a simple Linux machine, you can click on here and you will get a machine. If you want a Argo CD instance, you can click it here and it will give you a Argo CD instance. If you want an Ansible machine, you can click on here and you will get a Ansible machine. Okay, there are other things as well which you can access from here. For us, we are looking for Kubernetes. Okay, so we click on Kubernetes. Okay, and I can get a playground. I will click here and this will give me a Kubernetes cluster, okay, in a shortest step. Okay, so this way you get Kubernetes clusters like real easy. Okay, so what I'll do is I'll just click on okay, so this is my tab. Okay, and I'll just start it. Okay, um, here what you see is I'm on control plane here. Okay, so oh my bad. Okay, let me plug in charger. Just a second. Okay, perfect. Okay, so here we have Kubernetes cluster. So setting up a Kubernetes, if you want to get hands-on on Kubernetes cluster, you can use Docker Desktop. Okay, if you have Docker Desktop installed, okay, how many of you have all, Docker Desktop already with you? How many of you are is already using Docker Desktop?
Yeah, I have a connection.
You have Docker Desktop? Okay, perfect. So in Docker Desktop, there is a feature called Kubernetes. So if you go to settings, okay, if you go to settings, how to deploy Kubernetes with Docker. So if you go to settings, which is not showing up here. If I have a Docker Desktop? Yeah, I have Docker Desktop. So I'm starting my Docker Desktop and I can show you how uh, you can access Kubernetes on your system. Okay. So in Docker Desktop, there is a settings. Here, let me just bring it here. Okay, so this is my Docker Desktop. If you see, I have engine running here and I also have Kubernetes enabled here. So how did I enable Kubernetes? I go to settings, I go to Kubernetes here and just click enable and apply and restart. So when you enable this, you will get Kubernetes cluster on your system. Okay, so if you already have Docker Desktop, I will highly recommend you go with Docker Desktop Kubernetes enablement. Okay, so this is where I can get access to Kubernetes. Okay, so once you have Docker Desktop Kubernetes enabled, you can use a Lens uh, cluster. Okay, so Lens is a IDE that help you to access Kubernetes from your own your desktop, right? So I'll use OpenLens. I have OpenLens enabled. Okay, let me see if I have Lens here enabled. Okay, I don't have Lens here. Okay, I can click on Lens, but I need to install it. Okay, I'll install it later. But for now, what I can do is I can directly go to the playground. Okay, so once you enable Docker Desktop, everything should remain same what we are doing here. Okay, how to okay, so somebody is adding to chat here. Not to skip. Okay, perfect. All right, so the how do you interact with Kubernetes? You interact with Kubernetes using kubectl CLI. Okay, just like with using you want to talk to Docker, right? You use Docker command. To talk to Kubernetes, you use kubectl CLI. Okay, so one of the client that you can use to access Kubernetes is kubectl. Okay, so this is the uh, most used Kubernetes CLI. Okay, and there are other CLI like K9s. Okay, or you can use Rancher desktop. Okay, okay, desktop. You can use Open Lens. Okay, or you can use Mirantis lens. Okay, so Mirantis lens is more advanced version of Open Lens. Okay, and it also requires you to pay subscription if your company is like more than 10 million revenue per year. Okay, so all these are same. Okay, so all these are clients to access Kubernetes cluster. We will be going through the hardware. So kubectl is one of the CLI client. I can run this. So when you run, if you have Kubernetes kubectl command, okay, kubectl get pods will give you the okay. So first thing you will do is cluster information. Okay, kubectl cluster info will tell you the information. Cluster information. Okay, it will tell you information about the cluster. It says where is the control plane running. So control plane is running here. Okay, and the other service like core DNS is running here. Okay, to further, so you can get more information by passing cluster info dump, right? So if I place this here, I should get more information about the cluster. Okay, so what things you can do with Kubernetes? Okay, so the first thing you can do is you can do is you can create application. Okay, so create application deployment. Okay, so how do you deploy application in Kubernetes? You create pods. Okay, okay, so pods are the smallest unit for a workload. Okay, or I would say it is the only thing that does some work. Okay, so pods are atomic unit of any workload in K8s. Okay, so Kubernetes in short we also call K8s. Okay, and this is the only workload that consumes resources. Okay, so like this is the only object that will run in Kubernetes. Okay, so all other things revolve around pod. Okay, so if you understand pod in Kubernetes, the other services are just a manipulation of the pod. How to access pod, how many pods, like how to create multiple pods. So all there is everything in Kubernetes is wrapper around pod. Okay, so pod okay, so in just like in Docker world, we have container, here we have pod. Okay, and in Kubernetes, the pod creates one or more containers. Okay, and we will see here in a moment. Okay, so let's try to create a pod in Kubernetes. How do you create a pod? Okay, you create a pod by kubectl run, and you define the name of the pod. Okay, let's say busybox. Okay, busybox, and you need to pass the image, right? Because we are running a container image. Okay, we need the image name as well. Okay, because we wanted to run a container, so we need to pick some image to start with. Okay, so I will use busybox. Okay, and I need to use some code. Okay, so when you run this, it creates a pod. Okay, so I will run this command here, and it will create me a pod. You see, pod busybox created. Okay, and how do you list the pods? So you list pod using kubectl get pods. Okay, so now you see it is listing a pod, and then it is saying ready. There are certain columns that it shows: name, ready, status, restart, and age. Age is I think it is more expressive. Restart, it says how many times this pod has restarted. It says it restarted one time in 3 seconds. Now it says it restarted 2 times in last 27 seconds. Okay, it says completed here. Okay, so completed is nothing but the container finished its work. Okay, so let's make sure that this container this pod runs something. Okay, so what I will do is I just pass some command to uh, run in this box, busy box. Okay, and to do that. Okay, so you can get the documentation of this kubectl in a from the Kubernetes documentation. You get it from kubectl cheat sheet. Okay, so you click here, the first link will give you the list of command that you can run with kubectl. And if you are working with Kubernetes, this is the only place you will get all the commands in one place. Okay, so if you are working with kubectl, you don't need to go anywhere. Just go to this location and you will get all the details, all the commands, references, and everything. Okay, so I'll post it this one as well with you so that you can check it out later. Okay, so the first command we ran is we created a container, right? So how did so container is nothing like, it's like creating an object. So we have created a pod. Okay, and that pod runs something, right? So okay, so how do we okay, so let's try to create one more thing. Okay, so this wait, where am I? Okay, so this is not running anything. I can instruct this image to run something. Okay, so what I can do is, so let's copy this thing and search for all the run command available in Kubernetes. So you see here, you can run busybox and you can run pod in interactive mode. You will get a shell here. Okay, so I will just run this one. Okay, and you will see I will get a shell. Okay, I'll go here in the playground and I paste it here, and when I press enter, already exists. So it says the pod already exists. Let's give another name to this here. Okay, and instead of getting shell, let's do a sleep command. Okay, let's do a sleep, and this container shall sleep for 100 seconds. Okay, and I will remove this TTYI, and I don't want to run this in. So now you see kubectl get pods. You will see 2 pods, and this pod is getting created. Okay, so one of the container is getting created here, and if I run it again, you see it is running. Okay, and it is running since 14 seconds. Okay, so how do you get information about the pod? Okay, so the information you will be seeking for a pod is, okay, maybe you want to how to get information about pod. Okay, so what information you need, right? You need details about the pod. Okay, so instead of doing what operation we can perform on pod, right? Operations we can do with pod. Okay, so we can get details of the pod. So to get a detail with for a pod, you can say kubectl describe. Okay, and you are describing a pod, it's a pod and the name of the pod. Okay, so when you run this, it will give you detail about the pod. Okay, I go here and I paste it here. Okay, so it will give you detail about the pod, and this is a lot of information for you, right? At the start, you see that this is a lot of information. At the bottom of the uh, output, you will see the events that this pod has gone through. Okay, so the first thing it's you see, right? The pod was scheduled, right? You see scheduled. Okay, so this is the responsibility for the scheduler. So the default scheduler is the component that will schedule this pod on in Kubernetes. So it successfully assigned default busybox to control plane. Okay, so why control plane? Okay, so why control plane? Because we have only one node here. So how to get the node information? You can get the node information by kubectl get nodes. Okay, so nodes will tell you how many nodes you have in the cluster. So right now we only have one node. That is why all the requests are landing into control plane itself. Okay, and we will see how to add more nodes here. Okay, in the later session. But we were describing busybox, and it says it successfully assigned to some node here. Okay, and after that it downloaded the image. You see successfully pulled image. Okay, and it says again it successfully pulled image 3 times. Okay, and it then created a container called busybox. Okay, because we are running pod, right? Pod will create a container. Okay, if we specify multiple container, it will create multiple container. Okay, so and it says successfully pulled images again, and then after some time it says back of restarting because it was still creating, right? Okay, so these are the event you can see from pod. So if you want to check the history of the pod, what happened to pod, you can check the events. Other things are what is the state of the pod, what are the volumes attached to the pod, right? What are the containers in the pod? So right now we only have busybox here. Okay, and you see the state of the pod here, image ID, port, host port, all these are the same thing we worked with Docker. Okay, so in Docker, we specify port to use, we specify the volumes, right? It can access and the environment variables, right? All these things were part of the Docker as well, and same thing are here as well. Okay, so we created a pod, right? So pod is doing all the thing, but how do we check what the pod is doing? Okay, so to see what pod is doing, you need to check logs of the pod, right? So the how to check logs of the pod? How to check logs of the pod, because pod runs some application, right? An application must be writing some output. Okay, so how to check output of the application? You say kubectl logs and the pod name. Okay, and here you don't need to specify pod because the in Kubernetes only pod is an object which will emit logs. Okay, because other objects are not doing anything, they are just managing pod. Pod will be printing all the logs, so you check logs for pod only. So kubectl logs busybox will give you the logs of the pod with the name. Okay, so when you do this, right now we don't have any logs, but if you do for busybox one, nothing there as well. Okay, so why? Because the cluster, the application, the pod we ran, it is not running anything. Okay, let's run something that will emit something. Okay, so for that we will run nginx, and this is the nginx pod here. What I'll do is I'll just run this command, and you can also do this kubectl run nginx minus image equal to nginx, okay, and Nginx. Nginx. Okay, I'll press enter, and now you see kubectl get pods. So you will see the Nginx container is creating, and after some it will start running. Okay, you can get, so it is running now. Okay, and now you can check logs for Nginx by running kubectl logs Nginx. When you see the output of the Nginx pod here. Perfect. Like this is something running the application. This Nginx is nothing but a reverse proxy. Consider this as an application. Okay, so when we work with Docker, right, we created one image. Okay, if I go to Docker Hub, okay, I can also find the image name from here. Okay, so when we work with um, a container, we created an image. Okay, and that image was somewhere here. So let's find out the image name. Okay, Docker and Ubuntu. Okay, so let's find the okay. I need to sign in. Okay, we'll create an image. We will create a container, and then we'll create an application sample application as well at the end of the Kubernetes class. Okay, and let's see the concept called the next concept called the workload manager. Okay, so we understood the pod here. Okay, so the pod have an IP. Okay, what does a pod have? Okay, so the pod, okay, this is a pod. Okay, it has one or more containers. Okay, one or more containers. So one container here, one container here, one container here. Okay, so pod will have multiple containers in itself. Okay, and pod will have some volumes. Pod will have some data. Okay, pod will have an IP. Okay, pod will be listening. Will App will be listening on app port, right? So how do you access application from the pod? It is just like a container, right? So you need to access the container port, right? So this is application port. It has IP, it has data, it has some secrets, right? Secrets. Okay. So how do you give all this information to pod? Okay, secrets. Okay. So how do you get all this information from pod? And so these are done by the workload managers. Okay. So you created a pod, but you right now you're not seeing how to create multiple pods. Okay. So how to create multiple pods? You okay. So from the command line here, okay, we ran kubectl get, let's do get pod. We created three pods here. And how did we create it? We created using kubectl run and Nginx. Okay, you can run multiple times there, but now you need to change the name here. Okay, so I can just do Nginx run one. Okay, it will create another container, another pod. It will create the second pod by running this. So now if you see kubectl get pods, you will see three Nginx running here. One, this one, and this one. Okay, so there are three pods running here. Okay, but how do I achieve load balancing and high availability here? Okay, also how do I create these pod directly without running this command? Okay, so in Kubernetes, most of the time you will not run this command uh, like on the console. Okay, instead what you do is you create YAML files. Okay, so what is a YAML file? Okay, a YAML file is a way to create a Kubernetes object. Okay, so the Kubernetes objects are created using YAML syntax. Okay, so how do you get how do you know what YAML what is the YAML syntax? Okay, let's try to run this pod, and let's see what is the YAML of the pod look like. Okay, so I'm running this command. Okay, and here you will see I have passed this new flag called dry run. Okay, and I'm passing -o option to YAML. Okay, and I'm redirecting the content, the output of this file, output of this command to pod.yaml. Okay, so what does this command do? This command, instead of running nginx pod, it is trying to generate a YAML file that the kubectl creates and send it to API server. Okay, so what happens here is, okay, whenever you run a command, okay, you send a command here. So the API server here, right? This API server, okay, API server, it converts the YAML, it converts the data you sent here into a YAML file. Okay, it converts the data into YAML file, and this YAML file is deployed into Kubernetes in the cluster. Okay, so this command is converted to YAML, and then it is sent to cluster. Okay, so instead of the YAML file being generated on the fly, you can create a YAML file yourself and then deploy it, then send this YAML file to API server so that it doesn't need to generate YAML file itself. Okay, so how do you create a YAML file? You create a YAML file using the --dry run flag and passing it to pod.yaml file. Let's run this command and see how does our YAML file for pod look like. Okay, so here you see the most important part in the YAML file is the API version, kind, metadata, and spec. Okay, so other things are optional. Okay, so if I write it down, okay, if I write it down, okay, the YAML file of any object in Kubernetes contains following properties. Okay, following uh, uh, properties. Okay, so how many of you already know what is a YAML syntax? How to write a YAML file? Anyone? Like, you know how to write a YAML file? Just checking if I need to take a small session
No,
for YAML.
Prakash.
Yes. No?
No, Prakash.
Okay. So YAML file is nothing but they are uh, key value format file. Okay. So if I go to YAML syntax, okay, YAML syntax. Okay. So you can go to CloudBees as well. Okay. So this is a markup language. Okay, and this is used uh, in place of XML and JSON. Okay, so in old days, the first markup language was XML. Okay, so markup languages are nothing but they are used for defining properties for an application. Okay, so JSON, what is JSON file? So JSON file is a language of your internet. Okay, so all the data flowing in internet uses JSON format because and what is JSON format? In YAML, in JSON, you define a key and there is a value of the key. Okay, so if you write a JSON file, okay, if you write a JSON file, how does it look like? Let me bring it here. Okay, so how does a JSON file look like? You have curly braces, okay, and inside curly braces, you define some key values here, right? So let's say here name, right? So name is let's say Docker, okay, and you define another values. Employees, okay, okay, and here if there are multiple things, you define another curly braces and you define name, right? and I say open, okay, or just say A here, okay, and another name, okay, okay, and then you say D here, okay. So this is YAML format. It contains some key and there is a value here, some key and there is a value here, okay. So this is a YAML format. Same thing, okay, so no, not this is a JSON format and this is the language of internet, okay. But after some time, okay, this reading this file become a little harder for humans, okay. So there is another markup language came into market, which is called yet another markup language, okay. So in short, it is called YAML file, or it is also called YAML, okay. So if you see a file with syntax YAML or YAML, so this is a YAML format file, okay. In YAML format files, the keys and still it contains key, okay, and values, okay. It contains key and value, okay. Okay, so this contain key value, but instead of curly braces, it uses spaces, right? So if you want to create so if you want to create a child of a key, right? So let's say E, okay, and this is the key. Now, if you want to create a child of E, okay, so you can use space instead of curly braces here. You see, we use curly braces here because there were multiple employees here, and we wanted to add uh, a child of employees here. Okay, employees has multiple. So same thing you can do with, yeah, same thing is there for YAML, but instead of curly braces, it uses space. So YAML is totally based on space, okay, or tab. So what you can use tab, but if you use tab at one place, all other place you have to use tab as a uh, indentation, right? This is like 4 so this will come under E, okay. If you don't put space, this will come, the all A, C, and E will be on the same level. So how do you define keys in YAML? Okay, so you define key name, okay, key name, okay, and then you define values here, okay. Here, by default, everything is a string, right? You see, if you put something in double quotes, this is treated as a string, okay. If you put like name, okay, if you put like age here, okay, and you put some number here, so YAML automatically knows that this is this is a integer. So 23 will be taken as integer, okay. If you put uh, uh, list, what will say, package parcels, okay. So you are, let's say we wanted to add multiple things here. So how do you add multiple parcel? So you add multiple parcels by placing space after parcel, like you put things in a different names. So I want to put multiple parcel, you can use hyphen and you put parcel like one, okay, one parcel, two parcel, okay, three parcel. So there are three parcel, and this is equivalent to adding a list here. So let's say one, two, okay, and three here, okay. So this is equivalent syntax in here. So both are same, but this is more readable instead of adding like this, okay. So this becomes a list here, okay. So just like employee is a list here, parcel is a list here. How do I convert this JSON into YAML file? You can use name here and you can put Docker here, okay. And you can employees here, and in employees you have A, okay, okay, A, and you have B, okay, you have B here, okay. So this becomes a list here. So this JSON file becomes this, okay. And you see, reading this is a little harder, and this syntax is much easier to read for you, okay. Application can read this one and this one in same time, okay. They understand both in the same way, but if you are a human, you understand this language is a better. So a YAML was designed to be human friendly than XML and JSON format, okay. So there are many data structure you can create, you can have in in the YAML file, the main concept is key and value. Okay, so this value can be list, this value can be array, this value can be integer, this can be boolean. Okay, so if you put like another thing, say married, okay, and you say true, so this will be treated as boolean here. Okay, instead of string, this will be treated as boolean. So this will become a boolean parameter when you use a YAML string. Okay, so this is about YAML. Okay, same thing is there for Kubernetes. In Kubernetes, you create object in YAML format. Okay, so let me copy this and try to give an idea of what does a pod look like. Okay, so as I said you, there are four important things in any Kubernetes object. One is API version. Okay, the second is kind. Okay, or let's say it's a camel case, kind. Okay, metadata. Okay, and the spec. Okay, so these four properties or these four keys are the mandatory keys in any object. Okay, so these are mandatory keys in any KTS object. Okay, so whether you create pod, whether you create deployment, we will talk about deployment as well, whether you create services, whether you create jobs, whether you create cron jobs, all will use these four keys in their YAML file. Okay, so in API version, you see for pod the API version is v1. Okay, so what is this v1? This v1 is nothing but it is these v1 are the set of objects that you can create in this. So every object has a API version. So pod is part of v1. Okay, if you want to create deployment, the deployment is part of beta v1. Okay, because they came after pod was created. Okay, so kind tells you what is the object kind. Okay, so what type of object you want to create. This can so if you so in v1 there are many types of object you can create. Okay, and that list you can get from here. Okay, so if I go to here, okay, I say v1 objects. Okay, so you will see it will list all the objects in v1 here. Okay, so deprecated API reference doc, not here. So I can go to objects in Kubernetes. Okay, and you will see deployment. The API version for API version name is for deployment is app v1. So app v1 will contain deployment object. Okay, so where can I get information about the API version v1? Okay, if you search for that, click here and you will see some object in particular version. Okay. So you see v1 here, the kind of object you can create it apps. Okay, okay, I need to get the list of version here. Okay, so where can I get it? Okay, which version of API you can. So there are many list here. I think I need to find the specific way something changed here. Okay, I'll get it. API changes. Okay, something changed here. Okay, I'll find the API version for each one. Okay, but so what I mean to say is each version of API implements some set of objects. So you see, for example, suppose there are two API v1 and v1 beta. The resources in both will be little different, right? If you originally created, so v1 beta will have a new set of objects, v2 beta will have new set of objects plus whatever is part of v1. Okay, so v1 beta 1 will contain additional objects apart from v1. Okay, so each version implement new set of objects. So whenever you use some object, you need to know that what is the API version. So we create so v1 has pod, so kind is pod. Okay, this can be deployment, this can be service, this can be job, this can be cron job, this can be ingress controller. So there are many type of objects in Kubernetes. Okay, and you need to define the object that you are creating here. Okay, metadata is nothing but it contains information about your object. Okay, so let's say the object have some name, right? Nginx, right? Nginx here. Okay, it contains some labels, right? Okay, so labels like who created it, owner. Okay, so owner is like me, Paliwal created it. What is the app? It is a front end app. Okay, so label are used to search for the pod in the Kubernetes cluster. Okay, they are specifically used for that. You can define label as well. Okay, in the spec you decide what the object will do. Okay, so spec are particular to the kind of object you create. Because we are creating pod, it will contain containers. Okay, containers, it can create multiple containers. So let's say I want to create so this is like Nginx, right? So I will create a uh, Nginx pod. The name will be Nginx. Okay, and image will be Nginx.latest. Okay, and other information. Those only these two things are required to create a Nginx pod. Okay, if I run this, okay, and how do I run this? Let me close this one. I open another thing pod nginx.yaml. Okay, and I will paste whatever I have created here, and I will just rename nginx name, so that because this is already nginx here, right? So I'll just say nginx yaml. Okay, and I'll just save it. Okay, how to apply this YAML file or how to run this file? How you do kubectl apply -f. Okay, and then you need to pass the file path here. For nginx, press enter. Line 4 found character that cannot start any token. Okay, so this is because there is a issue here. Okay, because what happened? Okay, I use tab here. I cannot use tab here because I used spaces somewhere. So let's remove tab here. Other places as well. Here I used spaces, so we are fine here. Okay, let's copy this again. Okay, and I'll paste it here. And let me run this. Okay, now it says Nginx pod created, kubectl get pods. You will see one engine is running and it was restarted 7. Okay, so pod Nginx, I need to rename this. Okay, and I just add YAML so that I can create a new Nginx pod. Let me apply this again. Now you see Kubernetes pod created, kubectl get pods. You will see Nginx YAML running here. Okay, so this way you can create an object using YAML file, and okay, so we'll join again tomorrow, and we'll create more objects using uh, kubectl and see what are the use of those objects. Okay, so I'll stop here today. I need to join another meeting. I'll stop